In this question, we've got a steel girder AB and it has a weight of 210 newtons. Okay, so let's make a steel girder that is AB. We know the weight is 210 newtons, and we can also pick out the keyword, it is a uniform rod. So the weight is 210 newtons, so I am not writing 210 G's, it is just going to be 210. It is held in equilibrium, so we know the conditions for equilibrium. We can resolve the forces, and we can also take clockwise moments are equal to anti-clockwise moments. It is held in a horizontal position by two vertical cables. So one cable is attached to the end A, so there might be a tension A. The other is attached to a point C. So this is TC, where AC is 90 meters. So AC is 90 meters. I'm sorry, 90 centimeters. The girder is modeled as a uniform rod and the cables as light inextensible strings. Given that the tension in cable C is twice the tension in cable A, so I can say TC is twice TA. We have to find the tension in cable A. So because we know that the rod is in equilibrium, we can resolve the forces vertically. So that would give us all the forces going up, that's TA plus 2TA, is equal to all the forces that are going down, that's equal to 210. So we can say 3TA is 210, or the tension in the cable at A is 70 newtons. So that is part A. Right, so let's just pick up part A, and then maybe we can leave it somewhere there. Right, now for part B, we have to show that AB is 120 centimeters. Now, AB is the entire length of the rod. Now, I hope you might have noticed that we, because it is a uniform length, a uniform rod, we didn't exactly know where the middle of this is. So what we are going to do is, let's say this distance here, meaning the half of the rod, that is x. So if that is x, then I can say the remaining distance here is 90 minus x. So what we have done here is, I'm just assuming the middle of the rod is x centimeters away from A. So if I have to show that AB is 120, that's equivalent to saying if I can show that 2x is 120. Right, we've already worked out what is TA, so this is 70, and so this is 140 newtons. Right, so we can take moments, and then the easiest place to take moments would be, I'm going to choose 210. That point, let's call that point as M. So the 210, that kind of cancels off because that force is in line with my pivot point. So the next force that we know is the 70 newtons, and the perpendicular distance to the pivot point is x. So we can say 70 times x. We know that this force is going in the clockwise direction, the other moment that is happening is the 140 newtons. So 140 newtons times perpendicular distance from the force to the pivot point is 90 minus x. So that is times 90 minus x. So we now have 70x equals 140 times 90. We have minus 140x. So that means 210x equals 140 times 90. X would be equal to 140 times 90 divided by 210. So 140 times 90 divided by 210. So we have x is equal to 60. So because x is equal to 60, that means the other half would also be 60, and in effect that means AB, which is equal to 2x, is equal to 120 centimeters. So that is part B. Right. For part C, we might have to change the diagram a bit. So a small load of weight W newtons. Okay, so we have, let's just get the A, B, and I think C. Yep. So we have TA here. This would be TC. And in the middle we have 210. And then this distance was 60. So the remaining distance here was 30. So a small load of weight W newtons is attached to the girder at B. Okay, so we now have a load of weight W. Because the weight is W, I am writing it as W. If the mass was W, I would have done W times G. Right, the load is modeled as a particle. The girder remains in equilibrium. The tension in the cable at C is now 3 times the tension in the cable at A. So I can say this is 3 times the tension at A. Now, a common mistake that we can do is, it is very tempting to think, oh, we already figured out TA is 70. I could just plug that in here and then work out what is W. Please do not assume that, because when you have added an extra weight, the entire question that was relevant to part A and B is no longer applicable to part C, because you're entirely overhauling the system. Because when this new W comes in, it kind of changes everything with regard to the tension that was present in question A and B. So please do not think, well, I have already figured out what is TA, because this is equilibrium, I can then just resolve this and then figure out W. Please do not assume that. When you are changing something in the system, then the entire tension in the string changes, and we cannot use any of the answers that were used or found above. So please remember that one point. Right, so now we have this idea, we have to figure out what is W. So because this is equilibrium, in any moment's question, there are only 2 things that we can do. First, we could resolve what is going up and what is going down. So we have TA plus 3TA is equal to 210 plus w. Well, that means we can say 4TA is equal to 210 plus w. Let's keep that aside. The next thing we can do is we can take moments. So we can take moments about any of the points that we like, but ideally I would choose w so that I can get rid of, the unknown. If I had chosen a c or an a, both the t and the w would remain in the equation. So I'm not saying it's wrong, but it is a bit more convenient if we take the moments about b. So taking moments at b, let's have a look at the forces and the perpendicular distances. So we know that the entire length of the rod is 120, which means this is 60, this is 30. That would force this distance also to be 30. So we missed that length, so this is also 30. So the first force that we know is TA and the perpendicular distance. So let's just highlight the pivot point. The pivot point here is B. So the distance from the force to the pivot point, that is a total of 120. So we can say TA times 120 plus, and that moment is going in the clockwise direction. The other moment that is going in the clockwise direction is this force, which is the 3TA. So I can add that to 3TA, and the perpendicular distance is 30. So both of these moments, they are going in the clockwise direction, and the moment that is going in the anti-clockwise direction is the 210. So 210, perpendicular distance is 60. So that's 210 times 60. So now we have 120 TA plus 90 TA is equal to 210 times 60. So that's 210 TA is equal to 210 times 60. Cancel off the 210 and the 210. We get TA is 60. So tension in the string has now become 60, and then that is evidence that this is not similar to the 70 which we had earlier. So that is 60, which means 4TA now will become 240, and that is equal to 210 plus W. That means W is 30 newtons, and that is the value of W. And this is the first question. So what I want you to remember, or what I would like to reiterate again, is just because we found an answer from part A doesn't mean we can use that value throughout the other parts of the question, especially when something in the question has changed, or something in the setup of the question has changed, like adding a weight, or decreasing a length, or shifting any position. So if anything in your question changes, that means the earlier answers that you figured out, they may not be relevant in solving the other parts of the question. Right.